Hello and welcome to this tutorial. In today's tutorial we're going to create a simple customer counter, keeping in mind the COVID-19 virus and shops needing to keep a tab on how many people are inside their shop. So this is designed for stages 2 to 4. We're going to go from the specification, which is what the problem is, through to algorithms and then the implementation of how I code this. Now, just to let you know, there is an advanced version of this which uses several microbits instead of just one. So look for that video. It's the next in this series. The problem, as I said already, how do I keep a count of customers in my store using digital technologies? The constraints that we have are that there's one entrance or exit into the shop, and the worker who's counting knows the store limits of the customers. Our solution is going to be to use a microbit, and we're going to set a variable which is called counter. Initially we're going to set that to 0, and then we're going to repeat the following forever. When button A gets pressed, it adds 1 to the counter. Every time button B gets pressed, it takes 1 away from the counter. If the microbit is shaken, the current customer count is displayed for 2 seconds. So from that solution, here's our simple algorithm. So on start, we're going to create a variable called counter, and we're going to set it to 0. And then when button A is pressed, we're going to add 1 to the counter. When button B, we're going to take 1 away from that variable. And when the microbit is shaken, we're going to display the counter, wait 2 seconds, and then clear the display. Notice that in this particular algorithm, I have not had to do a loop, because using the microbit in make code, I don't need to tell it to loop. It's just going to do it every time it senses button A or button B or a shake taking place. So from the algorithm, you can see that indeed with the blocks, there is no looping system, there is no forever. But you can see that on start, we're going to set our counter to 0, so that's our variable. We're going to change it by 1 if we press button A. Look at this, we're going to change it by -1, so in other words, take 1 away if we press button B. And when we shake it, we're going to show the number of the counter. I've added in there to change the display back to nothing after 2 seconds. So if I click the shake button first of all, you can see that it's registering 0 because counter hasn't had anything added or taken away from it. If 1, 2, 3, 4 customers come in and I shake it again, it should say 4. And if one customer leaves and another 2 come in, what should that be? Okay, shake it and see, so we're up to 5. Then 3 customers walk out. I can't remember how many should be there now. Work it out. Right, it's 2. And then 5 more customers come in, but 2 leave. What should it be? 5, you got it right. Okay, so that's how it works. So from the blocks, you can now see that the code is going to be in Python, and I'm using Mu editor. So I need to import the microbit library, and I'm going to set my variable called counter to 0 to start off with. And then notice inside Python, because it's a different programming language, I have to work a little bit differently. I need to create a loop which will continue through forever. Now remember, this while true is simply another way of saying repeat forever. So while true, if button A was pressed, add 1 to the counter. Look at the syntax there, plus equals 1. If button B was pressed, then add -1 to the counter. So look at the syntax again, plus equals -1 this time. If the accelerometer was gesture shake, so in other words, if a shake is detected, then display whatever value is inside counter and scroll across the screen if you need to. Now, where does this fit? You can see that in the various stages under coding, it certainly fits in with using visual programs and using algorithms and branching and so on. Other relevant descriptors are also important. So to show how information systems meet personal, school or community needs, certainly meeting a community need. Defining problems in terms of data and so on. and drawing on previously solved problems and defining and decomposing real world problems. It certainly solves that. Where it could be used? Well, apart from inside of shops, which is the real world problem solver, so the customer scenario given, can also be used for a data collection counter. For example, if you want to count mini beasts in the yard, data interpretation and visualization. It can be used as a trigger for those sorts of things where you're capturing the data and then going on to interpret or visualize what that data means. And it can be also used as a maths tally device. Remember that there is a more advanced version of this in the next video, which uses 2 microbits and also uses the microbit radio function so that the microbits can talk to one another. Thanks for watching.